Question number 1. A bullet is fired from a rifle with a muzzle velocity is 100 meter per second at the angle 15 above horizontal. Calculate horizontal range. So if you draw the diagram here, we have a projectile motion of the bullet here. So we have look at the on the y and x axis, right? This is y axis and this is x. And now we have a fire from here. Velocity u is equal to 100 meter per second, and the angle theta here is 15, right? So now here is the question of you to calculate the horizontal range. So this is the horizontal range or R here. So what is the distance here from the start and moving upward, and after that going downward and back to the let's say this ground surface here. What is the R distance? So you can start to calculate the R here, because the velocity you can refer to the S or R, right? You can use R here divided by, right. So velocity is equal to the distance or displacement R divided by time t. So now to calculate the R here, you can use the R is equal to velocity time t, time. So now you must know the value of the velocity of the object and the time t here. What is the value of the t and velocity? Okay, as you know, for the projectile motion, the u for the, because this is, we talk about the horizontal, meaning velocity on the x or horizontal here, right? Rx also x. So meaning here we consider the ux. Here we have a ux, right? And just before hit the ground, also you have a ux. But for the ux is constant value, meaning you can find the value of ux. So if you use the diagram here, so we have a, this is you resolve u here to the u, y, and here you resolve to the x, we have a ux here. But you can resolve to, you have the value of the ux because you have a value of the theta and initial value 100 meter per second. So from the calculation here, you can find the value of ux, okay, resolve to the x axis. So this is a adjacent and hypotenuse. So meaning you have a 100 cos 15. So here is the value of 100 cos 15 is equal to, you can use the calculator, is 96.6, right, meter per second. And for the uy here, resolve 100 meter per second to the y, so the same process, uy is equal to 100 sine 15. This is 15 degree. So now for the y here, we have a 25.9 meter per second. So now, because here is a Vx, so already you can use the value 96. So V here is equal to 96.6. So the problem here is what is the value of the t. T here, you can use the equation S is equal to ut minus half gt square. So why? Because you can find the time taken from the objects starting launching to the upward and moving to downward and back to the ground surface. So you can find the value of the time t. To calculate the value of the time t, you just consider the object from the ground surface, okay, from the ground surface and up, maximum height, and up, after that moving to the original position. So meaning you consider the y or vertical axis. So here we have a focus on the y axis here. So sy is a displacement up and down. Up you can use a plus and down is a negative, because we have the same value here, so meaning plus minus, so sy is equal to 0. So what happened to the uy? Uy we have already calculate 25.9, and now you can find the value of the t here. So if you can use this is quadratic equation, you can use the calculator to find the value of t. Just write the final answer for the t is 5.28 second. So now you can have the value of the time t here. So the time t here is equal to 5.28 seconds. So now you can find the value of the r here, 96.6 times 5.28. So we have a final value of the r or range here is equal to 510 meter. This is the value of the r, right? Okay, thank you.